Welcome to Centerfield Armory. Today we are taking a look at the muzzle brake that I had made. You may have seen it in one of our previous videos. Likely, we only have 3 up right now. And it is a very, very effective brake. A couple of features is for one, simple attaches by sliding across the front sight post and then turning to a 90-degree angle. And then on the back there's a set screw, which honestly isn't very much needed, but it does make it so that it's very secure. It's a very tight fitting piece, and it took a lot of file work to get it to fit. So it's a very tight and secure fit. It doesn't really need the set screw. It's just there for my peace of mind and for others, I guess. It's a very heavy brake. That's just due to the materials that were available to me at the time. This was made in a high school machine shop. And so the original plan was that there was going to be 3 smaller holes of this diameter, and I do not have any of my drawings with me from when I blueprinted this out, but basically what happened was on this one, the reamer I didn't notice, but when I was finishing off my final diameter, had chipped a little bit. And then I did this one, and it blew up, quite literally blew up inside of this one. And after hammering it out, I had to move up to a 3/4 inch hole. So both of these are 3/4 inch holes just to clean them up a little bit, which actually works out to my advantage, I believe. Now, the diameter of the bore for this muzzle brake was, first off, the entire length internally from top to bottom, front or back, is one solid ream. Solid drill and ream. And that's a 0.59 inch diameter reamer. And this is actually the reamer that was used. This is from can't find it. The label on the I don't know, maybe in here. Nope, it doesn't have it. The label on the box has worn off. So this is a just a high-speed steel long reamer, and this is all that was really needed to get the job done. Other than that, the shop had everything that I needed. So, but obviously that this part right here was machined to fit over the end of the muzzle. Now, if we reverse it, that means that this side was too. Ergo, a round will sit right inside there. Now, I don't know how you can see these, but it probably doesn't look that nice internally. What I've noticed about this piece is that it's just I haven't cleaned it in a while, and I haven't noticed any rust start appearing on it. And I'm running standard bulk silver tip, which is, as you know, corrosive, and haven't had any problems with rust. So this is cold blued. There's nothing really special about that. And yeah, so I'm to say I'm pleasantly surprised is, yeah, it's pretty close. Now, the vent holes at the top, if you're firing in a darker environment, you can definitely see gases expel out the top very easily. And I think I can credit that too in the design. The hole right there is very close to the top of each of these side ports. And my theory when I designed this was that it would spiral the gases around this way. So this one, this one, this one, and this one expel the most gases up. These front two and these two right here, they do expel some gas, not nearly as much as the two center ones, or two center pairs, but it's a noticeable amount. Now, in all, this is a reiterating, this is a very, very heavy brake. This is just some cold rolled steel that we happen to have in the machine shop at the high school here. And I had made a prototype with much less material on it, and it had just poofed. It quite literally back from behind a tree and all that. Pull it with a piece of paracord. Pull the trigger with a piece of paracord, and it cracked from here to here. It wasn't a bad crack. It only went in a very little bit, but I just totally scrapped it. Said, you know what, I can do better. We still don't have the greatest materials, but I just have to add a little bit more material, leave a little bit more material on. So that's all I had to do. So it was quite simple to make. I turned this on a World War II era Monarch lathe, and then all the holes were bored. The top was flattened, and the bottom was flattened on a Gorton mill that's made its way all the way up the Mississippi to us. Nothing on here is CNC'd whatsoever, all manual machined and then hand fitted with a file. I'm working on becoming a CNC machinist, but at this point I'm pretty set with running a manual mill and lathe, and I can hold my own at least. So yeah, I'd say now for reduction of recoil, felt recoil, I don't have a pad or anything on there, and I'm not a very built person. I'm fairly lanky, and due to lack of physical activity on my part, I'm getting a little chunky. But I'd say, now again, this weighs approximately, I'm going to say at least 5 pounds. So with this, it's a bench rifle. I mean, it's a bench rifle. It's a heavy rifle to begin with, and then you add 5 pounds onto the muzzle, and you have to hold that out. It's hard to do standing very easily, for me at least. For me now, it's a bench rifle, and that's the way it's going to be. I like shooting from a bench, so. But I digress. Recoil reduction, this will probably, here's your 7.62, 5.4. Now, that's just standard silver tip military bulk. But to me, felt recoil on this is reduced so well that I'm pretty sure it's comparable, if not exactly, between 5.56 and a 7.6239. This round recoil was reduced to somewhere between these two. I'd say it's leaning more towards a 5.56 in the bolt gun configuration with no brake. I mean, a very smooth AK action, or SKS, or a VZ58, or whatever semi-auto 7.62 you're running. This is very darn close. This is just some Tula from Walmart, but there you go. Somewhere in between there. A full power rifle round. So, in my opinion, not bad for when I was in high school. So.